created some slides on the introduction. I promise not to bamboozle anybody with a lot of functors and all those stuff in Scala. It's going to be basic. So this is an introduction to Scala. I am, as he earlier said, I am Mohammed Kabir Idris. I work for SW Global, and I'm ongoing MSc in Artificial Intelligence. I love Scala so much. I love MGS. I am on Twitter, and a lot of some people may know me in Abuja. We could do Meetup and the Scala Meetup. So to start with, where does the name came from? Scalable language. So the first three letters, and for scalable, and the first two for language. Scala multi-paradigm programming designed to express common programming patterns in a concise, elegant, and type-specific way. Scala is not the only one on the JVM. We have Clojure, Groovy, Java, Noctel, Claron, and the rest. They all have the same similitude, but Scala seems to be an edge above most of them, probably because it tried to marry some two people together in the object-oriented program. A lot of us are good at object-oriented, but for graduate trainees in Scala. Meetup.com uses this on filter for its all back-end routine. SoundCloud uses CC, Java library, and cat library for tons of things. eBay also uses it. Everybody uses Scala. Maybe some may be using it 20, 30%. Some may be using it full scale, like Twitter. It uses full scale. Foursquare also same. Netflix same too. So in practice, Java is a good interpolator with Scala is a good interpolator and replacement for Java, and all existing Java applications can run on Scala seamlessly. You can, just the way you know how to build data types, the Boolean, byte, short, int, and we have collections, set, maps, tuples, options, iterators. So inference. Scala is static, and what that means is for every variable you declare, you must have a type to it. But it tends to make life a lot easier sometimes, that you don't need to know the type. You don't need to write explicitly the type. It infers the type for you. Like the example we gave, val sum. Val sum, you do 1 plus 2 plus 3, and it gives you this. So what the Scala repo does is it tries to infer the type. These are integers, and it infers the type for you. By normal standard, you are supposed to write var sum. It should be an int which is equal to 1 plus 2 plus 3. So it gives you the same thing. Same thing for all other types. So this tells you, like the example here, we have a map which is equal to a map of the key is a string and the value is a list of integers. I did not explicitly state that, but based on Scala inference, it was able to understand that it's an immutable collection map that have a string as a key and a list of int as the value. So it's kind of help you type less when you writing real programs. Same here. So Scala tries to, behind the hood, write a lot of help you with a lot of boilerplate codes. So I implemented an uppercase, high-level uppercase for Java to check if a variable has an uppercase and return either true or false. So this is a lot of code that I have written. How many lines? Lines of code. But in Scala, you don't need to do that. There are what we call the high order functions. The name, and it's going to do the check for you. Like this example. In Java, you have 8 lines of code. In Scala, you just have one. So if you have example, is equal to Lagos Scala group. So we could just do this name Tony Boolean. Same thing as that which we did here in Java for I equal 0, take the length of the string, check if the string at the point I is up. So there are a lot of boilerplate codes you need to write in Java. You need to set private variables. String, var, age, int. By var, it's simply automatically gives you the setters, the getter and the setters for you. You don't need to write any boilerplate. P1 that age I get it p1 dot name. I can get it p1 dot age is equal to 31 age. It automatically set all these things for you, so you don't have to set as the type. You can change the variable. While val is immutable. This is mutable, and this is immutable. But that doesn't mean that you can change from Boolean to a string or from an int to a string. Scala would not allow you to do that. So if you have var full is equal to full, it can't be, you can't change it. You can only destroy it when you shut down the JVM. But you can't do this. Bar is equal to full. And reassign to a val. This can sometimes you think is something very, very weird. Why should you not be able to change variables? But it's one of the foundation and the principles of concurrency, because sometimes you want to allocate another different thread to compute and something for you. But if it changes all values, then there is no guarantee of what is returned. How sure are you that in if it's a value, you can't assign to it, so you're very sure that this same type of value I sent to the other thread or to the other computer to recompute and return back is actually the same value I created. So let's look at the object-oriented aspect of Scala. Everything is an object in Scala, so it means all values are objects. If you create, example, if you create, say, one to string, makes it a string. You can say that one have a method to string. A simple mathematical addition, subtraction, multiplication are all methods that are inherited by int or boolean or the rest of them. So if you do, let's say 1 plus 2 plus 3, you get 6. But in real term, it's actually 1 dot plus 2 dot plus which gives you the same thing. So everything is an object. All you just need to do is, if you want to know more about all the methods in an API, yeah, there's it. So you can just type, let's say, int, the Scala int. You can see all the functions that you can use for Scala. int. Traits allow you to implement the functions. You don't only define the functions, you implement the functions as well. So if you have a trait that has been extended by another function, that function doesn't need to implement all the methods in the trait. It's those ones implemented in that trait will automatically be functions of that object. Let me cite and let me give an example. Let's say you have characters, maybe a movie character, and let's have trait for attributes of each of the characters, and we want attributes, and we defined, let's say, the environment that character environment that character has more strength in. Let's say that environment is a string. This is not implemented. Let's say the weapon the character uses, let's say, is a string, but here we'll define it will be equal to, let's say, gun. So if we create, say, class character, it's the name of the character, name is a string, and extends this trait's attributes. If I try to submit this, I'm going to get an error because I have not implemented the environment. So if I try it, it tells you the environment is not implemented. So what I would do is I will implement the environment. I'll override if environment is a string, which is equal to, let's say, land. So now we have our character. So we can say val new character. Oh, new, I created this new character, let's say Naruto. So now we can say Naruto that weapon because it extends from this. So if you have a hierarchy of attributes, you can build traits. And the beauty about traits is a character can have millions of traits. If we create another trait, let's say another trait, mood, and in his mode we define as let's say mood, which is a string, and we defined is always happy. That character is always happy, and let's say mood. Yes. So if we create our class again, okay, let me correct this character attribute extend. We use the width method, and we'll say mode. Then we'll implement define environment environment is a string which is equal to Kakashi. So we could do Kakashi and his mood. He's always happy. We can override that in our definition. If we go, we can override, okay, let's see, mood. Um, let's say we want to override the mood, the string, and it's sad. So I need to also implement on that of environment. Environment. That's fine. So I can define this. Traits are very useful tool to use in creating a hierarchy in your application, because you can use with another mode, with another trait, with another trait, with another trait, and it makes object-oriented principles easy for you. So I did the same for traits JVM, trait, excuse me, static. So when I extend the Scala class, extend the language class, which I defined here, with JVM, with static. So when you print it, you see, because I overrode the two string functions, you see, Scala, JVM, static. So we have this also, the singleton object. In Scala, there is nothing like a static object, unlike in Java. So you don't use static object. The only thing you do is you create singleton objects, which can also be very, they are very important in Scala. They can extend classes, they can extend traits also. Singleton objects, you just create an object. So it means if I create an object, say Lagos Scala group, so I can decide val num members, which is equal to a list of Mr. A, Mr. B, Mr. C. So this is a singleton object. So globally, I will be able to refer to this without creating a new object, and it doesn't change any, without changing any of the variables. When I click on members, I get the list. I don't need any new, create a new instance of it. This very instance can be viewed globally based on the package I have put. Hello?
Go on, Kabir. We can hear you. Go on.
I think we should continue. Okay, great. I'm going to the most interesting aspect of it, which is the functional aspect of Scala. That is where you have so many people complaining they don't, it worth the time spent in trying to understand everything about it. You benefit more when you are able to grab most of this functional stuff. They are not magic. They are just simple tricks. But it takes an x, which is an int, and it returns an x plus 1. So the equal to greater than is a sign that is an anonymous function. Once you see something like this, equal to greater than, then you're sure that is an anonymous function. So we can write that takes an int and returns an int. And that's the meaning of int equal to greater than int. So if you do res 10 and you put 5, you get 6. You can assign it to a value like this. Still an anonymous function, so you will be able to use it. You can do val plus 1. I created a small stuff. Is an object. We have a function. There's a function for mean, and there's a function for standard deviation. So I can take this function and put it here. There's a function inside a function, and Scala is happy with that. What it simply means is, based on visibility, the scope of this main function will only be visible to the standard deviation function. You can't use it outside here. So it makes life a lot easier. For functions that you don't need them to outside, you can just simply put them inside other functions that uses them. So closures, the values that you can use inside other functions, and you can change. You can use it inside an anonymous function and it will return a value. So go high order functions. When you see yourself writing Scala application and you're writing for each, you're trying to iterate a collection, then you must be doing the wrong thing. Scala made it easy for you to, with the high order functions. These are functions that actually accept other functions. So take an example. One function is a function that takes an int and returns an int. So we have these functions that takes functions. Remember, I earlier said that everything is an object in Scala. So it means collections have a lot of functions that are high order functions. Not only collections. Most of Scala data types have this. So if you, let's have an example. You have a list, numbers, a list of 1, 2, 3, 5. And we want to add 1 to each of them. This list is a collection that have a lot of high order functions in it. So if we do, the most basic one is map, which means I iterate over each of the elements inside the collection. So if you do map and say x, let's do n as an anonymous function, n plus 1. This will add 1 to each of the values inside the list. And we can still do the same thing. Instead of map, remember the +1 function we created? And pass it like this. The +1 function is same here. It takes an int and returns an int +1. Same as this, an int and returns an int +1. So if you do the same, you get this result. For short, if you want to create a short form of it, is the underscore. The underscore means each value in it +1. Each value inside the num +1. So this is like our iterator. It's the same thing as this whole x equal greater x. It's the same thing as the underscore. So we have other ones like exist. This will check if the value, it will take a function, like exist will take a function that takes an int and return a boolean, either true or false. So if we say num dot exist that x is equal to 2, that if there's a value equal to 2 in this list, it returns a boolean called true. Yes, we found a value 2 in our list, which is this. And there is a find. Like the find is like the select statement in MySQL. So it takes a value x and it takes a value and search the list to find if it exists. So it can either be yes is available or no we don't have. And that's why Scala returns something called a sum. A sum is a collection which is either a collection which is inside an option. In Scala, we try to avoid null pointer exceptions in your code. And the best way to do that is to enforce the user to either check, is it the sum or a null? So what should happen? In other applications, languages like PHP, you tend to always write out your final values. And what happens is if some other person is using your library example and he doesn't check if the value returned is actually a null or an actual value, you see null pointer exceptions even in production. So Scala tried to avoid that by using an option which find returns an option. So if you do nums dot find, what it's saying is I want to find if any of the elements there is a 2 in this list. So let's say x, where x is equal to 2. So it returns the sum. Yes, there is. If we do, it returns an option of a list of an int. So if we do same x is equal to 2 p1, it returns no, there is no x. So you cannot use this directly. You have to check, and then you use it. If it's a null, then you try to pass the right exception you want. Index where will tell you where the index is. There are tons of them. There's a reduce left. The reduce left is a function that actually takes two functions and so example is this reduce left. What it does is it takes the first one, which is this, and it takes the second on the list 2, which is this. It adds them up to make it 3. Then it replaces it here to be 3. Then it takes 3, and this 3 will be here, and it adds it up to make it 6. The 6 now will come back here, and it add to 4 to make it 10. That's how I got this. So if you do, oh, sorry. Reduce left x. This is more of a shortcut to reduce left. But actually, what reduce left does is, let's say sum is of, let's define a function, an anonymous function val sum that takes x as an int, y as an int, and return x plus y. Is an anonymous function. Val is equal to is an anonymous function that takes 2 values and return the last one. So reduce left can use this function because it will take the first 2 values, sum them up, take that sum and put it as x, take the third value, sum them up, reduce left from the left side, keep reducing the list till you get a final value. So we can do nums that reduce left, and I pass the sum function. This gives me 12. So this is a very powerful tool where you think of it like you have a list of students and their scores, and you pull them from the database. Instead of writing for each to get the maximum, the highest score in the class for that subject, you do another for each to get the minimum. You do another for each to get the average. You can pass these functions into things like for each or whichever of these high order functions, and you get your results in a more elegant way, because this is a lot easier. Imagine if you have to do for each to get all this stuff. I would have written like 6, 7, 8 lines of code, but with this or with this, it makes it a lot easier. So where are we? Oh, high order functions. It's okay. So you can pass, this is the same thing as what I have done here. I created a high order function. You can create your own high order functions. For example, we define call. Let's see, this is a function call. It takes f. But what is f? Is it a string? Is it an int? It can be anything. But in this instance, f is a function that takes an int and returns an int. And we call it this way. We'll say f. If we call f1, it's not very intuitive, but we can define our own high order functions and create them as straight, and extend our list, and we'll be able to use them. I think we've exhausted 30 minutes already. Should we continue? Hello, organizer.
Yes,
Hello.
yes,
Should
Kabir.
we continue?
Can I just unmute everyone at this point? 1 second. So we've done 30 minutes. Would you guys like to continue?
Unmute everybody so that we can have a discussion, or maybe there are questions.
Everyone, so any questions you'd like to ask Kabir at this point? Everyone is unmuted now, so I believe you can all speak directly.
Before we continue.
Okay, there doesn't seem to be any questions. Would this be, so we've done 30 minutes. Would this be a good time to stop, or would you guys like to continue?
Yeah.
So personally, I wouldn't have minded if we continued. I think the only question I had so far, I think I asked, and Ikena responded to. So that's for me anyway.
Kabir, how many slides do you have left to go?
Okay. I have 44 slides. I'm in 29.
Wow,
It's a lot of
it is
a lot of slides, but we can speed up. I think what we should do is we can stop at high order functions. Let me finish high order functions, then we'll stop. Then we can schedule another time to proceed with pattern matching and the rest.
Okay.
There are a lot of things that I believe newbies must have learned, and they need to enhance on it. Right?
Good plan. Good plan. Let's do
Hello?
that.
So I think let me finish. Let me finish high order functions, then we'll stop here for today, and hopefully we will continue subsequent time. So is blocked, so nothing will happen. When Scala tends to use multiple threads to execute, so you can use tail recursion to effectively do a lot of things. I will give you an example. Let's implement it. Print out the list, the items in the list. So I will short this. I will short my repo. I'm going to short it. I'm going to use, there's another repo called Ammonite. I've installed it on my system. I'm going to use that because it's a lot easy. You can find it here. I open and it also takes f is a function that takes int and returns a unit, something printable. So we can do this we're going to show how tail recursion works in higher order functions. So we'll say if X, the list is empty, if it's empty, what should we do? We return the head of the list. That is, if it's not empty, we put the function X that the head of the list. The list have the methods called the head and the tail. You can get it in the API documentation. So we take the head of the list and we print it. We're going to use print. Else, we take the each here can be called that is tail recursion, and we'll take the list, we take the tail, and function, which is this, then I'm going to make some explanations on this. Oh. So easier for you to go back without having to, if it's not empty. It's okay. The parameters 2, 3. We use print. Print is a function that takes anything and returns and prints it out to the repo. So it prints out all of this. So let me explain. What we have done here is we keep repeating the tail recursion. We keep repeating the function, calling it inside that same function repeatedly, do the same thing. So as long as it is not empty, you take the head of the list and you print it, and you take another head, you print it, you take another head, you print it. So let me take, let's say list 2, 3, 5. So in Scala, the head is the first element, and the tail are the remaining elements. So if I do res3.head, it returns 1. If I do res3.tail, it returns the rest as a list. So what this function do is it checks if this list is not empty. If our list is not empty, it passes the head, this head, to our function. And our function is a print function that takes anything and print it. It can be anything. We can put this maybe as a database save method. So what it does is take the list for each of them, take the value, save it. If it's, as long as the list is not empty, then the each now has the same signature as this, where our list XS is the list of the tail, which is this, and fun is our function that takes an int and a list. So it keeps tail recursive. It continues until it finishes. And when Scala sees a function that calls itself, what it does is it takes that function and put it in a different thread so that it doesn't stop executing. It takes it to a different thread. Once that thread completes the recursive function, it returns the value to the main thread and execution continues. So you don't have anything like Stack Overflow on the main thread in Scala. If you see that, then you must be doing the wrong thing. Then I think I've explained this. So there are other things. I promised not to make it cumbersome, but this is the same each state. Remember we did
So,
an each for a
sorry,
list of an each.
sorry, Kabir. There's a question for you on the chat around tail recursive functions, and basically the question is, what's the difference between this in Scala and tail recursive?
Yes.
I think tail recursive in Java.
Okay. There's a lot of difference in that the annotation tail recursive makes life a lot easier, one. And I'm going to explain more of the benefit here. Like, this is a type class. The previous one we did was a list of int. What if we wanted to implement a list of people to print? So we have to write the same function again. What if we wanted to implement a list of strings, a list of booleans? We can do something like this, where T is the type. T is the type. You can see X is a type of T and returns a unit. And then we do it returns a unit, and then we do a pattern matching to check what is the type of T. Sorry, we do a pattern matching for X. If it's nil, we don't do anything. If it has a head and it has a tail, then we should be able to do function head and it returns. So if I implement this function, I can use it with any type of list. Copy, let's see, paste. So I have created the each, which is quite much of a generic each that takes anything. So if I have, let's say a class, let's create a class of person that takes a name, which is a string. So now I have a list. Let me create a list, val L, which is a list of people, new person, name, also another new person, name, Kina. So I've created a list of people, and I can use this for each. I can do, each, and take the list, which is L, and print. Sorry, I wanted to introduce something. Let's do a case class. There is what we call a case class that help us do toString by default. So let's do a case class of person instead of doing okay, so we use this instead of okay, so we should be able to, yeah. So now with this each function can do everything as long as it's printing a list to a string. This is one of the powers of generic programming in Scala. I think we should stop here for now. There are more of the slides which I think
okay.
You can go back. I will share these slides to your mails, so you should be able to have access to them and try to play around with what I have done and see if it really makes sense.
That's great. Thank you very much, Kabir. Just to make sure that we've answered Ozor's question, I don't know if you wanted to just talk a little bit about the tail rec annotation, just to make sure that Ozor is happy this question has been answered. Just the tail rec annotation. Do you want to say anything more on that, or
the tail rec annotation? Yeah, I think I've said much I have known. Once Scala sees a tail rec annotation, what it does is it said, this is a tail recursion. We don't know how long
okay? Yeah. Okay, cool. Cool. I think yes, we lost your voice. We lost the audio a little bit there, but I think Ozo is happy now that that his question has been answered. Okay, thank you very much. On behalf of everyone, I just want to say a very big thank you to Kabir for that excellent presentation. It's given us quite a very good intro to Scala, and we've seen kind of an intro to the functional programming powers of the language. Like Kabir said, we're going to send out that that slide on the Meetup group, so that everyone would receive it. And if you're not on the Meetup group, I'd really suggest that you join the Meetup group. I'm going to send out the link in the chat right now, so that you get it and you sign up. So it's meetup.com/Lagos Scala. Do sign up so you receive all our emails and other information. So that is it, people. That is it. Thank you very much for joining, and we hope to speak to you some other time. Thank you. Did you want to say any other last thing, Kabir?
No, not much. I think we need to publicity, and people should try and understand that where we are today in software application is more than just doing code. So some things may be a bit worried, but if you give it a try 1, 2, 3 times, you should be fine with it and to move on.
Cool. All right. Okay, then. Thank you very much, Kabir, and thank you, everyone. See you later. Bye-bye.
Yeah, thank you very much. Yeah, bye.